Here it goes.
Wow.
Greetings and welcome, friends. We're taking a look at the quadratic formula and the discriminant today. However, even though you've seen the quadratic formula perhaps before, today we're going to, well, just you wait and see. We'll call this discovery. Discovery, and with an exclamation mark, so it's exciting. All right, suppose I thought of just a plain old generic quadratic equation, right? So that would be like ax squared plus bx plus c equals 0. Am I right? I'm right. Let's say for this quadratic equation, now you don't have to write this part down, I'm just deriving this for you.
Wait, what should we write? Oh, wait. So
Yeah, just the title, but let me keep going here.
Yeah, okay.
So here's a generic quadratic equation, and we know that we can write any quadratic this way with different values a, b, and c, blah, blah, blah. What if I solved this using completing the square? What if I did that? Well, the first thing I would do would be move the old c to the other side. All right, hopefully this is familiar to you. So I'd have ax squared plus bx equals negative c. All right. Then what would I have to do? Oh, it's got an a term that's not necessarily equal to 1. So what should I do, guys?
You have to divide it by everything by the term.
Divide everything by a.
God, you don't write that.
Okay, all right. Yeah, people can if they want. So I'll have x squared plus b over a x. I'll write that a little bit there. Bam. Blank equals negative c over a blank. Right? Now, Hank, how would I find my new c term?
Why do you always ask me this?
Because you remember it well.
You have to divide b over a by 2, right? And then square it.
Right, so this quote-unquote b that I'm referring to is now, in fact, this entire b over a. Okay, so we'll do b over a divided by 2 and square it. So dividing a fraction by 2 is the same as
Doubling it.
double the denominator. So b over 2a all squared. What's that going to equal? Over 2 squared is a squared is a squared. So I'm going to add b squared over 4a squared to both sides. Is this getting awesome yet?
No.
This is amazing. Here we go. Now, the left-hand side, this guy, fast factors. You guys know how to factor that. What's that going to be? Plus b over 2a all squared equals, oh, I need a common denominator here.
Oh.
Guys, so let's see, between 4a squared and plain old a, what would I have to multiply this by? Well, it's missing a 4, and it's missing another a, so 4a over 4a. So that's going to equal up top, negative c times 4a. I'll just call that negative 4ac over 4a squared down bottom, plus b squared over 4a squared. And now that those are over a common denominator, I can add their numerators. And just because I don't want to have the negative term first, let's put the positive b squared first. So that's going to be b squared minus 4ac over 4a squared. All right, what do I do now, though, friends? Root, both sides.
Okay.
Plus or minus. And on the left-hand side, I'll get plain old x plus b over 2a equals plus or minus. Let's see this numerator. Can I cancel the square with the square? No, because I can't distribute a square root over subtraction. That would be muy illegal. So the numerator is the entire expression b squared minus 4ac. For the denominator, square root of 4 is 2. Square root of a squared is a. And let's see, I'm getting close to solving this riddle. Minus b over 2a minus b over 2a. Hey, those are common denominators. So behold, I could write that as a single fraction, right? Where the negative b and the plus or minus this guy are all in the numerator. So this will be, are you ready for it? Here we go. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Wow, that was amazing, guys. We just discovered the quadratic formula. What? And when does this work? Anytime I have a quadratic in standard form and I know the values of a, b, and c, I can just like straight up plug those numbers in. It'll tell me what x equals. Both answers of it, in fact, because the plus or minus. Can you believe it?
No, I really can't.
Believe it. Because we just proved it using completing the square.
Wow.
So, quadratic formula, what does this mean? This means we can now solve equations with a formula instead of having to think very hard. And since the quadratic formula is related to completing the square,
We can use calculators to figure it out.
partially, but also it means that it works on every problem as opposed to factoring, which only worked on some problems. That's a terrible box. There we go. So let's solve an equation. Solve using quad formula. Bam! Here we go. Check it. Actually, let's even solve a problem that's kind of friendly. Man, I don't know. What do you guys think? Should it be friendly?
Yeah, it should be friendly. We're friendly people here in Math
Let's
3.
do this
That's
one.
why I school.
2x squared plus 4x equals 30. So, for this problem, is this in standard form? No. What do I need to do? I'll subtract 30 from both sides, set it equal to 0. So just like with factoring, standard form, and using the quadratic formula, you have to have it set equal to 0. I heard a really good idea over on the left side of the room. Divide by 2. Now, technically, I could have said a equals 2, b equals 4, c equals negative 30. All plugged it into the quadratic equation. However, we can make this simpler for ourselves where our math will have smaller numbers, meaning I'm more likely to be able to do it in my head, which is good. X squared plus 2x minus 15 equals 0. So, behold! What is A, B, and C?
1, 2,
Excelente.
C.
So, A and B are just the coefficients of the quadratic and linear terms, respectively. And yeah, C does look like a smiley face. He's smiling because he's all like, I've got a formula to do this work for me.
He's also negative.
Oh, or he's just wearing like a funny hat. Yeah, I could see that. So anyways, let's plug this in. Here we go. X equals the opposite of 2 plus or minus the square root of 2 squared minus 4 times 1 times c, which is negative 15. Jacob is texting all over 2 times 1. I know you want to tweet your friends about discovering the quadratic formula right now. That's really awesome. I know. It's pretty great. But quadratic formula solving this problem for us. Here we go. So that's negative 2 plus or minus. Let's simplify this. 2 squared is 4 over, what's that, 15. Negative times negative is going to be positive. 4 times 15 is 60. What? All over 2 times 1 is 2. So x equals negative 2 plus or minus the square root of 64 all over 2. What is the square root of 64? So negative 2 plus or minus 8 over 2. And now I've simplified this problem as far as I can. Well, I guess I could do a little bit of a cactus thing on this, but I won't, because now I've just got to break up the plus or minus into both of its cases. So either it's x equals negative 2 plus 8, which is 6 halves, or negative 2 minus 8, which is negative 10 halves. And now I can just simplify those. X equals 3, or x equals negative 5. Solved it. Man, quadratic formula, once you get it all plugged in,
That's so sick.
it's just like PEMDAS, all right? You just have to do order of operations through this. Now, common mistakes on the quadratic formula. Ready? This is where people make mistakes. They take the square root of just the first number, or they try to break the square root over the plus sign, right? So make sure this vinculum, this fraction bar, goes the whole way over that. Other times, people don't quite get the all over 2a, and they don't have this fraction bar under this. They just have it like under here. And then it's like negative 2 plus or minus that, and that's super wrong because this negative 2 is in the numerator. Other times, people get super excited about the all over 2a, and you know what they do? They're just like, all over 2a. And how do you have an equal sign in a numerator? It doesn't even make sense. So just beware, make sure you're consistent with your vinculums right there. It's going to be muy importante. And then other errors is people don't plug in using parentheses. So if this was like a negative 2 I was plugging in, if they didn't plug it in with parentheses and they just had negative 2 squared, technically that should equal negative 4. But what's funny is people will make 2 mistakes and still get the right answer because they double their mistakes. And I will take off points for both mistakes. That's right. I don't just be like, well, they got it right in the end. I'll say, no, they were wrong twice in the process.
Wow.
So make sure you use parentheses there if you're plugging in a negative. Be cool, friends. Now, you've seen quadratic formula before, a bunch of different problems. Sometimes this radical cannot be reduced. Sometimes it will be negative. And if that was the square root of negative 64, then what would that be, Jacob?
It would be negative 8.
Well, square root of negative 64 would actually end up being I8, right? Yeah, exactly. So, I8. So if there's a square root of negative, simplify it, right? If there's a square root of, if this was like just the square root of 8 itself, I would have broken that up into the square root of 4 times the square root of 2 and get 2 roots of 2. So use all of your radical reduction skills, use your complex number skills, all of that stuff would be awesome. Now, turns out there's a new thing you're learning today, the discriminant. Discriminant. All right, and the discriminant, the letter D, is equal to a portion of the quadratic formula. It's equal to the b squared minus 4ac. Yeah, that does look like a scared face. He's like, what? Discrimination? That's a bad thing. And I'd say, in some cases, yes. But the discriminant is going to discriminate what kinds of answers we have. It will tell us, it kind of like sorts them into categories. It'll tell us, are the answers rational numbers? Are they irrational numbers? Are they imaginary numbers? Do I have 2 answers, 1 answer, no answer? It's going to sort it all out for us. Other times the discriminant is called, ready for this? It's called the radicand, the radicand, let's see, cand of the quadratic formula. Because where do you find b squared minus 4ac in the quadratic formula? Where is it hiding? It's under the square root. That's called the radicand. Radicand. So that's what I'm talking about. So, and I want to point out that this does not include the square root. It's just the plain old b squared minus 4ac. Now, b squared minus 4ac tells me a bunch of cool information. All right, let's sort this out in maybe some sort of table. So let's say D is positive and a perfect square. All right. This is what this will tell me. I'll make like a table here or something. So if D is positive and a perfect square, well, think about what happened in our situation over here. The radicand was positive 64. So it was positive and a perfect square. What kinds of answers did that result in?
Whole answers, not fractions.
They are irrational? Rational. Now in this case I agree they didn't have fractions in them, they were integers. However, sometimes they could be, for instance, what if this 8 was like a 9 or something, and then this would have been like 7 halves and negative 11 halves. Those wouldn't have simplified, but they still would have been rational. So what I want to point out is that if it's positive, I will get 2 solutions, 2 real solutions. And if it's a perfect square, it turns out that those solutions will be rational numbers. And little side bonus fact, if your answers are rational numbers, meaning they don't have any square roots or nothing crazy in them, it means that the original problem is, catch this, is factorable. So a whole bunch of information you can pull just from finding out what is this little b squared minus 4ac equal to. Okay, so that's case 1. What if d is positive and is not a perfect square? Just plain old number. Well, I will still have 2 real solutions. But let's say instead of the square root of 64, what if that was like the square root of 65? We couldn't have simplified that, meaning my answers would have had some plus or minus square root of 65 all over 2 sort of situation. Those would be irrational numbers. Right, where they still would have had some sort of square root in it because they weren't perfect squares. All right? And if they're irrational numbers, that means their decimals are infinitely long, non-repeating. And also, that would tell me that it's not factorable originally, but I won't specify that. Okay, a couple more possibilities. All right, what if d is equal to 0? So it's not positive. What happens if I have the square root of a 0? What do I get? 0. And what happens if I have a plus or minus 0 to something? It doesn't change it, right? Adding 0 and subtracting 0 is going to give me the same value. So instead of 2 real solutions, I'm just going to have 1 solution. And it will be rational. Right? Because the square root of 0 is 0. Adding and subtracting, it's going to give me the same value both times. And the last case for the discriminant, which, by the way, you do have to have these memorized tomorrow.
You told us that the quiz was on Thursday.
No, I said it was
You changed it.
correct, yes. That is what we
So
talked
you
about
want
at the
to
beginning of the
memorize
week.
them tonight,
Yeah,
which is impossible.
incorrect. We're fine. We're good. So let's see, if d is negative, what does that mean for my solutions? What happens when I have the square root of a negative?
Imaginary.
They're imaginary, so I have no real solution, but I have 2 complex solutions. And most of these are intuitive, so I wouldn't necessarily say you'd have to memorize it. It'd be better if we just, understood the concepts there. But I think it makes sense.
Intuitive.
Like, you could possibly gather some of this information just by thinking about square roots in most of the cases. So let's do an example of this. So exemple, this is sometimes the way that your text or other places will write it. They'll say determine the nature
Here.
I don't need more.
of the roots. And sometimes they'll even say specify using the discriminant or something like that. So roots, by the way, is synonymous with x-intercepts. Let's see if I can write that nicer. All right, which is also the same as zeros. All right, those are all synonyms with one another. All right, just so you know. And the nature of the roots means they're not necessarily looking for the answer. They just want to know what kinds of answers are we going to get from this. Let's see. Whoa, I'm lagging out. Whoa! Do you guys see that? That was crazy sauce. All right, wait. My tablet shut off. It's powering back up. Here we go. There we are. Haha, problem solved. Let's see. There we go. Everything's good. So what I mean by nature of the roots, this is what I mean. That's the nature of the roots. How do they behave? What kinds are they? You know, are they rational? Blah, blah, blah. How many are there? Yeah, so there you go. So let's do a problem together, friends. What if I've got x squared minus 8x plus 16 equals 0? So in order to use the discriminant, I have to know what? I need to know A, I need to know B, I need to know C. And we know where to find A, B, and C. I know where they live. I come to your house. A equals 1, B equals -8, C equals 16. So let's find the old discriminant. Here we go. B squared minus 4AC, right? Is what D is equal to. So let's just plug those in. So B squared, -8 parentheses squared, friends. Oh, not equal sign. Minus 4 times A is 1 times C is 16. So let's see. So that's going to equal -8 all squared is positive 64. Minus 4 times 1 is -4 times 16 is -64. And I get equals 0. So 0 is not my answer. That's the value of the discriminant. So what does that imply about the nature of the roots?
That is solution. ED is equal to 0.
So one solution, and it's rational. Bam. So that's what that implies to us based off of the little chart we just made. Okay? Let's do maybe one more. Perhaps one more,
That's
friend.
all I want you to do.
Yeah. Now, on tonight's homework, I think they'll blend the problems where they'll give you something and they'll say, use the discriminant to find the nature of the roots. And then they'll say, and then solve using the quadratic formula. So then you'd go and finish solving this
With a
and
calculator?
verify it. You could use that along the way, but you'd still, of course, be showing your work because that's what you would do. So let's see. Last problem. What if I've got 2x squared minus 9x plus 8 equals 0? Would I divide everything through by 2 on this one? Yeah, because this guy is not divisible by 2. So let's just figure out A, B, and C. What do I got? 2. -9. Ocho! Here we go. So, plug it in the discriminant formula there. Bam, -9 parentheses squared. Don't forget your parentheses. Minus 4 times A is 2, B is 8. -9 squared is 81, minus 4 times 2 is 8 times 8 is 64. Remember it now, forget it no more. That's how I remembered it in 3rd grade. I don't know about you guys. 81 minus 64, let's see, 17. So that's the value, okay. So it's positive. So how many solutions do I have? 2 real solutions, because there are plus or minus the square root of a positive number. It will give me 2 numbers. And it's not a perfect square, so that means these are irrational. All right, so that's the idea behind the discriminant. You're using it to kind of like analyze the types of answers we're going to get. All right, friends, thanks for watching. Bye-bye.